Hello everyone, welcome to my channel. This is an educational channel, and we look at, in particular, a lot of different theories of everything. I guess when I say a lot, we haven't quite gotten to several of them, but today is the 300th video that we have done on the reciprocal system of theory. And this reciprocal system was first articulated by Dewey B. Larson in the 20th century. He put out his two fundamental postulates in the late 1950s, and then went from there, polished them off, and turned them into, went through a process of deduction to identify a theoretical universe from which he wrote books on chemistry and physics and astronomy, but also economics and religion, philosophy, psychology, biology. Didn't write books on all those, but at least chapters in books, but full books on all the scientific subjects and the economics. We've covered some of those in some of those earlier videos, and we will get to some more later. Today we're looking at an article that was written by one of his acolytes, a person who followed along with the reciprocal system. And after Larson's death in 1990, he kind of came to the fore, although he was involved with the movement earlier than that. But his name is Dr. KVK Nehru, professor from India, and he writes an article here that's called The Space-Time Universe. And we're reading from that. I believe today is the seventh episode that we've done on this. So if you want to go back to the start of this article, you want to go back about six episodes and start from there. The basic idea behind the reciprocal system is that we live in a universe of motion. That kind of flies in the face of legacy science, which generally, attributes the contents of the universe to be matter or possibly energy. But in Larson's system, matter and energy are just two varieties of motion, along with really all of the other scientific quantities that you know of: speed, acceleration, force, pressure, electric current, and a lot of different electrical quantities, capacitance, resistance, magnetic flux, permeability, permittivity, viscosity, density. These are all kinds of motion, and they all can be expressed exclusively in terms of space and time. Because for Larson, motion, the whole universe is made out of motion, and motion was the relationship between space and time. That sets up a general reciprocal relationship between space and time. Motion is basically a fraction or a ratio, with space or time as the numerator and time or space as the denominator. Space and time have no independent existence. They only exist together in motion. The analogy that Larson would often use was a box. The box itself is motion, but if you have a box, then you automatically have an inside of the box and an outside of the box. And the inside was akin to space, the outside was akin to time, or I suppose vice versa. And, that's how that goes. Once you have one, you have all three: motion, space, and time. Larson actually, originally, when he came out with his postulates, he referred to to motion as space-time. As it evolved, he toward the end of his life, he actually referred to motion as being just change in 3 dimensions. And the 3 dimensions part is what comes from his first postulate. Universe is made out of space, is made out of motion. Motion's relationship between space and time. Space and time both have their coordinate aspects, meaning that both of them come in 3 dimensions. And both of them have their progressing aspects, meaning that both of them come as a scalar motion, a motion that has a magnitude, but it has no particular direction. Larson called that clock time and clock space. The clock is always getting later and later and later and later, but in no particular direction. And so too, space is always getting farther and farther and farther apart, but in no particular direction, which you can envision using a balloon with dots on it. Blow up the balloon, all the dots are moving away from each other. This is akin to the progression of space. The Hubble telescope also did reveal that all of the distant galaxies are moving away from each other. There's another illustration of the progression of space. Time and space also, coming from the first postulate, have only discrete units. They are quantized. There is no, fractional or continuity involved in time or space. They come in chunks, very small chunks, but chunks nonetheless. If you don't have a full chunk of space, then you do not have space. You have to have a full unit of space before you have it. Same with time. And if you have exactly 1 unit of space in 1 unit of time, you have what Larson refers to as unit speed, or the speed of light. So the speed of light is the unit speed, or really the background or the reference point, the origin, the 0 point, the state of rest in a universe of motion is the speed of light, outward in all directions. So that basically flies in the face of legacy science. Einstein would say that the speed of light is the maximum speed of the universe. Larson is really saying that the speed of light is the midpoint of the universe, and there's an entire half of the universe that is moving faster than the speed of light that Larson calls the cosmic sector. And this whole cosmic sector is something that the legacy scientists know nothing about. But they could close the gap fairly quickly, because you can extrapolate from the material sector, the slower than light half of the universe, to the cosmic sector because of the reciprocal relationship between space and time. And so what's going on in the material sector is exactly the same as what's going on in the cosmic sector, except that you just have to reverse the roles of time and space. So in the material sector, you have 3 dimensions of space, and you have clock time. These are familiar relations to us. In the cosmic sector, if you cross that speed of light boundary and move to the cosmic sector, you have the reverse. You have 3 dimensions of time, and you have clock space, or progressing space. And these are relations that are not familiar to us, but we can still use that same principle to extrapolate what we know from the material sector to the cosmic sector, with a few caveats. But anyway, so that's what Larson started with, and then eventually he derived his theoretical universe and wrote his books. And now Dr. Dr. Nehru, along with the other guy named Dr. Bruce Perret, have done great work in kind of not only resurrecting Larson's theory and making it a little bit more popular. It's still not like popular; it's still very, very obscure. But also, they worked with some of the shortcomings of the theory. The theory itself didn't really have the shortcomings. It was really the way that Larson applied the theory. He made a few mistakes, and they kind of revised some of the mistakes. And so they came up with what they call RS2, the reevaluation of the reciprocal system. And now Dr. Perret passed away about 3.5 years ago. And I believe Dr. Nehru is still alive, living in India. But we're going to start this article from part 4. This is really an overview article, the space-time universe, and it kind of goes over some of the outstanding achievements of the reciprocal system and just goes over them briefly, how the system has been plugged in various fields and to various subjects, and what it comes up with that is kind of different than what you would get from the mainstream legacy science treatment. Okay, so we'll start with part 4. In the previous 3 articles of this series, we have firstly shown how the concept of the universe as consisting of units of matter contained in a framework provided by 3-dimensional space and 1-dimensional time lead theoretical physics into its present predicament. We have then traced the development of the first general physical theory called the reciprocal system, and shown that every aspect of the physical universe can be derived without any ad hoc assumptions from occasion to occasion from its fundamental concept, namely that the physical universe consists of units of motion. We have examined space and time, the phenomena of radiation, matter and gravitation, electricity and magnetism, from the point of view of this new basic concept. So those are the kind of the areas that Nehru has covered already in this article that you would find if you went back and watched some of the previous videos here. The new understanding of magnetism leads also to a novel explanation of the origin of isotopes and the conclusion that the material atoms evolve in time. It points out that the nature of matter varies in this respect from location to location in the universe. One cannot fail to recall kindred statements in the Secret Doctrine and the Mahatma Letters of Blavatsky. It is not normally realized that the concept of space as extension permeates to a large extent almost all of our scientific and non-scientific thinking. For example, theosophists are inclined to imagine that the mental body extends in space despite repeated admonitions from investigators like it says Arthur Ellison, but I believe he means Arthur Eddington. I could be wrong. And just incidentally, this article originally appeared in the early 1980s in the Theosophist magazine, and so that's why he's talking about Blavatsky and the Secret Doctrine and Theosophists in general. He's writing to kind of an audience of Theosophists, and whatever you might think about theosophy and how it's evil or whatever, Larson was not using that paradigm, or it was not. I don't believe Larson was in any way aware of any of this theosophy when he was writing. Nehru is kind of trying to fit it into that compartment, and I haven't really read any Blavatsky, so I don't really know whether he's accurate in doing so, but that's just where he's coming from. And to me, it's not terribly relevant. We envision the universe of atoms, stars, and galaxies as stretched out in a background of extension space. The new understanding of motion brought out by the reciprocal system reveals some properties of space and time that are altogether not suspect hitherto. When we are dealing with translatory motion, space manifests itself as extension. This is the familiar entity that we normally visualize whenever the term space is used. When we characterize space as an aspect of motion, however, we introduce other kinds of space, since motion can be vibrational or rotational, as well as translatory, and one of the two reciprocal aspects of this vibrational or rotational motion is space, even though such space does not constitute extension in the usual sense of the term. Incidentally, this leads Larson to explain, among others, the reduction in the velocity of light traversing a material medium, the electrical resistance, etc. The knowledge of the true nature of space as a component of motion and as not having existence independent of its reciprocal, time, shows that space, as we are prone to imagine it, is no such static background at all. We have already seen that the reason why we seem to see a stationary three-dimensional space is that the inward progression of gravity counterbalances the outward progression of space. In fact, space or time is not even physical, only motion, as asserted by Pythagoras. By overcoming this fallacious view, which misled science and common sense for over 4,000 years, we become ready to take the next step onto the stage set by Larson to unravel further secrets of space-time. This section is called the conjugate universe. We have seen that the material atoms and subatomic particles are vibratory time units rotating in space. Now, the symmetry and reciprocity between the properties of space and time postulated in the reciprocal system thereby also require the existence of matter whose atoms are vibratory space units rotating in time. Somewhere in the universe, Larson calls these structures, which are exactly like the material atoms except that the roles of space and time are interchanged, the cosmic atoms, or C atoms, and cosmic atoms collectively as cosmic matter. This answers to what is conventionally referred to as antimatter by scientists. Of course, with a difference, antimatter in this view is not an additive inverse, but the multiplicative inverse of matter. The reason why we do not see aggregates of antimatter in our space is at once understandable and is no subject of idle speculation, as in the conventional theory. This is because the gravitation of cosmic matter acts inward in time, in view of the scalar rotation that constitutes a cosmic atom is rotation in time and not inward in space, as in the case of a material atom with its scalar rotation in space. The cosmic gravitation, therefore, draws the cosmic atoms together in time, forming aggregates in a three-dimensional time. Thus, we are led to the necessity out of the existence of another half of the universe, the cosmic sector, so far not suspected of in the least, with the roles of space and time interchanged, a universe of cosmic matter, cosmic stars, and cosmic galaxies, distributed three-dimensionally in time, but progressing outward in space. Another reason for not being able to observe the cosmic sector of the universe is apparent now. Since the cosmic stars comprise of cosmic atoms aggregated in three-dimensional time, but widely dispersed in three-dimensional space, we do not see them as spatial aggregates at all. Further, since a cosmic atom is moving inward in time due to the gravitation in time, while the material atom is moving scalarly outward in time, even the chance encounter between them does not last longer than for one natural unit of time, which is 1.52 times 10 to the minus 16 seconds. 6.576 quadrillionth of a second. The sudden disintegration of the exceptionally stable particles like the protons that is currently the subject of intense theoretical and experimental activity in physics can be easily explained on the basis of their chance encounters with the atoms of the cosmic sector moving inward in time. Thus, we see that there is another half of the physical universe right here and right now, but not observable by us. However, this does not mean that we have absolutely no communication or contact with the conjugate sector, as we will presently see. In view of the reciprocal relationship between the respective constituents of the two sectors of the universe, the radiation from the cosmic stars at high inverse temperature shows up in our sector as radiation of low temperature. Moreover, such radiation originating from cosmic stars, which are not aggregates in space and not localized in space, does not seem to be coming from any one direction. It would be isotopic. That's a typo. It would be isotropic and uniform in space. We have exactly such phenomena, namely the absolutely isotropic and uniform background microwave radiation at 2.7 degrees Kelvin, which is, of course, currently being misinterpreted as the radiation left over from the hypothetical Big Bang, with which our universe is assumed to have originated. Once again, like in the case of the recession of the galaxies, we find that there is absolutely no need to resort to ad hoc assumptions such as the Big Bang. I may note here that due to lack of space, I am refraining from mentioning a host of the astronomical phenomena which either stand unexplained or could be explained only with the help of ad hoc desultory assumptions by the conventional science, come out as logical conclusions from the fundamental postulates of the reciprocal system. Okay, I think we're gonna leave it right there for today. The next section is called Galactic Death and the Quasars. So we'll get into a little bit of astronomy tomorrow. Again, just try to stick with this stuff. You know, he's hitting you with a lot of different material from a lot of different fields, all kind of at the same time. And so you just have to let it wash over you. If you have different notions in your head, just suspend them for long enough to let him say his piece, and then you can let it, let all of it, kind of mix around in your head, and you can discern, what makes sense and what doesn't. But it doesn't do a whole lot of good to just come at it like a cynic, and just, reject it as soon as you come up with any type of excuse to do so. You're just really protecting your own, your own ego that way, and you need to have an open mind to get into this, to even access it at all, and because it flies in the face of much of what we've learned, much of what you've invested your time in, you've invested your money in, you've invested your reputation in. And so you have to really have an open mind to look at this stuff. And certainly there are some mistakes, certainly there are some questions, but that doesn't necessarily mean that you should just be rejecting it out of hand. Okay, thanks for tuning in today. We'll see you tomorrow. Have a great day.